In HypoCompass, we ask students to role-play as teaching assistants. They need to do 2 tasks as TAs, write a comprehensive test suite, and explain bugs given buggy programs, which correspond to our learning objectives. Comprehensive and accurate hypothesis construction. The first task a student needs to perform when they enter HypoCompass is to write a test suite for the problem at hand. The student can enter a test case and there will be a hint if the student's input or output are invalid. They can drag test cases to some test categories and also create their own test category. If the student is satisfied with their test suite, they can submit their test suite and start interacting with fake students in the Office HypoCompass simulator chatbot. The simulated students like Bob, Chelsea, and Dave, each coming to the Office HypoCompass with a different buggy code, which is displayed on the left. Now the student can then evaluate their test suite against Bob's buggy code. If their test suite does not reveal any bug, there will be a hint suggesting the student add another test case. After seeing a bug-revealing test case, they will then go ahead and select a test case on which they will explain, and then an explanation for what the bug is. Students will need to select from a pool of explanations. There's 1 correct option and 2 incorrect distractors, and different feedback will be given when they select correct or incorrect explanations. If students send an incorrect explanation, Bob will be confused and ask why. This incorrect explanation talks about how the buggy code only continue to check the loop if num is equal to key, which doesn't exist in the code. So Bob asks, if that's the case, shouldn't an input where the numbers list is 1, 2, 3 and key is 1 give me 2? My code would output none. If students send the correct explanation, Bob will fix the code accordingly. The correct explanation is that the code immediately returns none if the first number in the list is not greater than the key. So Bob says, I see. I've moved the return none statement outside of the for loop. And in display, the buggy code got updated with a side-by-side before and after diff view. The student can reevaluate the test suite and see the test cases all pass for this updated code. And these are all feedback provided to a correct explanation selection. After fixing Bob's problem, students will hop back to the Office HypoCompass and start helping Chelsea. This whole process is providing deliberate practice on hypothesis construction. We provide multiple bug examples to expose students to a wider range of potential bugs, and also this is a problem they've seen in screening tests to reduce the program comprehension difficulty. We provide example code and automatic fix so students don't need to worry about writing code. Furthermore, this whole role-playing with simulated students setup is taking a teachable agent framing, which helps improve engagement and provide a self-efficacy buffer. For each buggy code, we have the student workflow explicitly following the debugging process model, and the steps are in alignment with our learning objectives and the task to do as well. So that's the basic system interaction design. For more details, please refer to our paper. Thank you.